So we are Group Sophia, and we decided to do Assessment 7 from Calculus AB Quarter 1. And our group is me, Ishan, Stephanie, Peter, and Mickey.
So for question 2, the question is asking to find the volume rate given the radius rate and the diameter at a certain time. So first you write down your knowns, which is the dr dt, the radius rate of change, which is 1/5 centimeter per second. And we're trying to find the change in volume. We have the diameter, which is 25 centimeters, meaning the radius is 25 over 2 centimeters. And we're given the volume equation, and then we have to derive both sides. So it's going to be dv over dt is equal to 4/3 pi times 3r squared dr dt. And from there, we plug in our known values, which is just r and dr dt. And then after some simplification, like canceling out the 3, the 4, and stuff like that, we get 125 pi centimeters cubed per second. So for this one, you're going to make sure you have your units correct. And when simplifying, make sure you simplify correctly, squaring the 25 over 2 and things like that. So for question 3, you need to use the linearization equation. So at x equals -2, the equation is f of -2 plus the slope or the derivative at -2 times x plus 2. And then after simplification, this just goes to ln of 1, which is 0 plus ln of, and then then you have to derive ln 3 plus x, and from there you're just going to get 1, so it's just going to be x plus 2. So from that you have y is equal to x, the lx is equal to x plus 2, and you plug in your negative 1.5, and you get 0.5. So then you have to determine if it's an over or underestimate. So we know that it's an overestimate because the ln of 3 plus x is going to be concave down from finding the third derivative.
So for question number 4, this was a particle question. So the first thing I did was look for the velocity function and acceleration function because I was sure that they would have to be used at some point. And then for letter A, it was asking for average velocity. And so I went back to that formula that we learned where it was S of B minus S of A all over B minus A. And after plugging in the values from the position function, I was able to get the answer. And for this, I had to make sure that use the correct units because there's miles per hour, and miles per hour squared. And then for B, it was asking when it's moving to the right. And for this, the velocity function would be used here because you want to see when if it's moving to the right, then the velocity has to be positive. And so I did a number line, and seeing that it was positive between 0 and 5 showed that it was moving to the right on that interval. For question C, this was asking when the particle was first at rest. And so I used the velocity function to find the acceleration function. And then from there, I found when the velocity was 0, and that was at t equals 5. And then so I was able to plug that in and find when the particle was first at rest. And then for D, it was asking the total distance. So for this, I had to find the zeros of the velocity function. And to do that, I found when v of t was equal to 0, and that was at t equals 5. And then what I did was I plugged it into the position function, and then I've just added the distances between each of the different times. And then for E, it was asking when it was slowing down. And recalling from class, we defined when v of t and a of t had opposite signs. And so to do this, I just drew number lines for both to see when they were positive and negative. And then I was able to kind of look at the number lines and find that there's different on 0, 5 and 10, 50. So for this problem, I just had to make sure that I was very organized because things can get messy pretty quickly. So that's something to know about it. And then another thing is just making sure to use the right units because there's a lot of units and a lot of points can be taken off just from not writing the correct units or writing units at all. For 5, this was so for finding g of b, we were given that f to negative 1 of x is equal to g of x, which means that we can solve for g of x by just plugging in 4 on the left side and saying that equal to f of x. And then that would give us g of 4 of 1, g of 4, which equals 1. And then define g prime. So for this problem, we have to recall a function, a formula that we learned in class, where g prime of x is equal to 1 over f prime of f to negative 1 of b. And plugging that in, we could get the answer. So for this problem, it's mostly just remembering a formula. Going into a test, it's just good to have this formula memorized as it would be seen.
So for question number 6, you want to find the rate of change of the depth of water at a specific height. You're given the radius and the height of the cone and how fast the rate of the volume changes. So you know you're trying to find dH over dt, which is the rate of change of the height. The formula for the cone is volume equals 1/3 pi r squared h. In order to differentiate, you want all your variables to be the same. So in this case, you want to put all the variables and make them all h's, because later when you derive, you're going to have dh over dt. So you can set up a ratio r over h equals 3 over 4, and you get r equals 3h over 4. And then you can plug that into your volume formula. From there, you can simplify, and your volume is 3 over 16 pi h cubed. Then you take the derivative, and it's implicit differentiation because you're taking the derivative with respect to t. Then when you take your derivative, you want to isolate dH over dt, and then plug in the values. And you have to plug in h equals 3 because it's the height at 3. And then when you simplify, you get the rate of change of the depth of the water at the time when the height is 3 inches is 32 over 81 pi inches per minute. A common mistake could be that you plug in the wrong height when you're substituting in your values, and you plug in the height of the cone. And also, you forget to do implicit differentiation, so you want to watch out for that. For this problem, you're finding the derivative of y equals sine pi x to the g of x, and g is a function. Because g is a function, you can't do power rule or any other rule like that. So you're going to have to use e to the ln. When you do that, applying natural log rules, you can get e to the g of x times ln of sine pi x. From there, when you differentiate, you're differentiating something like e to the x, but it's a whole function. And because they're two functions multiplied together, you have to do product rule. So you get e to the g of x natural log sine pi x, and then on the right is all the product rule. The g prime of x ln sine pi of x plus g of 1 over sine pi x times pi cosine pi x. There's 1 over sine pi x because when you take the derivative of natural log, it's 1 over that thing. And then the right side combines into pi cotangent of pi x. And then you can simplify the e to the g of x natural log sine pi of x to just sine pi of x to the g of x. And then just simplify your answer as much as possible. A common error would be not using e to the natural log of x, because it's not super common in class, but it's a good thing to know for the test.
for A, the cost of producing 100 toys is C of 100, and they give you the function 0.1x squared plus 120x plus 800 for the cost. So to find the cost at 100, just plug in 100, and what you get is $13,800. And what that means is how much money you need to pay to produce 100 toys. C of x is the cost, and so therefore C prime of x is the rate of change of cost. And so you take the derivative of the function they gave you of cost, and you get 0.2x plus 120. If you plug in 100, you get $140 per computer sold. And what this means is that for every step in computers sold, the cost of producing the next computer changes by $140. So the 101st computer will cost 140 more than the 100th computer. For question 9, it gives you the distance from the base station, which you can put as z, and it says it's 17, and it gives you the distance above the base station that the plane flies, and it says it's flying horizontally, so that won't change. So to find y, or the distance horizontally, you use Pythagorean theorem, so x squared plus y squared equals z squared, and the 15 is given for x, and the 17 is given for z. So solve y for y, and you get y equals 8. And then to find how fast the variables are changing, take the derivative of the Pythagorean theorem, and you get 2x dx plus 2y dy equals 2z dz. So plug in values that you have, and you know that x is not changing, so dx is 0, so that's going to cancel out. And you know y equals 8, so plug in that, and z equals 17, and dz is given as negative 400. And you can solve for dy, and you get negative 850 miles per hour. So you know that y is changing to the right by negative 850 miles per hour.